These are your 2-4 notes on solving equations. Again, now this time when we solve these equations, we're going to have variables on both sides, and then we might have to clean up the equation before solving. So something like a distributive property or combining like terms might be involved. So if you have variables on both sides of the equation, we need to get them to one side. So we're going to use addition and subtraction properties to move the variables so that they're on the same side. We want the variables on one side and all other numbers on the other side. So we're going to use inverse operations, just like before, and then we always check our solutions in the original problem. I'm not going to perform a check every single time here. I'll show you maybe the first one. It is time consuming. I know you know how to do the checks. A little bit different when a variable is on both sides, so I will show you one of those checks. So if you look at this first example, you can see that the variable c is on both sides. So we have to decide which side do I want my variable on and which side do I want my numbers on. I typically try to have a positive variable or move it to the left. So in this case, it works for both. I want this negative 2c to go over with the positive 5c. So to make it leave the right-hand side, I need to make it equal 0. So a negative 2c, I'm going to add 2c. Whatever I do to one side, I have to do to the other. And then just be really careful with your work here. So I'm going to use arrows. I'm going to bring down the 8 plus 7c is equal to 7. And then the 2c and the negative 2c cancel. So I write this from left to right. Now I have my variable. It's being multiplied by 7 and adding 8. We're right back to where we were before, multi-step equations. I'm going to subtract 8 from both sides. I'm going to show all my work nice and neat. Draw my line. This cancels. 7c is equal to negative 1. And then when I divide by 7 and I divide by 7, c is equal to negative 1/7. And so there's our answer. To see if that answer is correct, we need to plug it in. So I always just use the same equation, so the original equation, write that down. But this time when we check our answers, we won't have the two sides matching until the very end, because the left side is going to change because I'm going to plug in a value for c, and the right side is going to change. So I get 8 plus 5 times negative 1/7. We're checking, does that equal 7 minus 2 times negative 1/7? We don't know yet. I'm going to multiply. And when you multiply, I get 8 minus 5/7. And I'm wondering if that's the same thing as 7 plus 2/7. So you can use your calculator's fraction keys if that helps. So if I take 8, take away 5/7, I end up with 7 2/7. Or if you wanted to, we could write that as 51/7. And 7 plus 2/7, which I just said was the answer anyway, is 51/7. So you can see we really didn't see that they were going to match up until that very last step. Even the step before, they were different. So the fact that the two sides match up tells me that my answer is correct. Now you're also going to solve equations where there may be grouping symbols like parentheses or brackets. So we're going to first use the distributive property to remove the grouping symbols. Then bring the variable to one side, then use inverse operations to solve. So in this example, we have to distribute both sides before we can begin. So I'm going to take the 1/3 and multiply by 18. It's the same thing as dividing by 3. I end up with 6 plus 4d. So I multiply both of those terms by 1/3. And then on the other side, I'm going to multiply both terms by 6. So I get 12d take away 42. When I go through this, I want to bring my variable to the same side. Again, I like to work with positive variables. So I'm going to choose to subtract 4d from both sides. You are allowed to subtract 12d from both sides, and it will give you the same result. So just make sure you show your work and we can follow along your processes. Bring down the 6, the positive 4d and the negative 4d cancel, equals 12d take away 4d is 8d, and then bring down the negative 42. Now I want to get the d all by itself, so there's my variable. Right now, 8 is multiplying that variable, and we're subtracting 42. So I'm going to add 42 to both sides. 6 plus 42 is 48. And then I'm going to divide by 8, and my d value is equal to 6. Same thing when you check here, you plug them in. Your two sides of your equation will not match up until the very end. So I'm not going to have you check today only because sometimes the check gets more complicated, but I want you to understand that it could happen. You could do it. You plug in the value for the variable and the two sides should match up. Sometimes we have equations where they have special solutions. Sometimes when you solve, the variable completely disappears. And so when that happens, you might get no solution. And that happens when the variable goes away and the two sides don't match up. It'll say 5 is equal to 8. Well, 5 is never equal to 8. 5 equals 5 and 8 equals 8. So if you get some answer where the variable completely goes away and the two sides are mismatched, you simply write no solution, or you can use the empty set symbol, no solution here. Same thing happens though. You might get it where you have any real number will work. So the variable disappears again, and it doesn't matter what the variable is. This will always hold true. 5 will always equal 5, or -2 always equals -2. So basically, in both situations, the variable goes away. You just got to look at the remaining information. If it's never true, like 5 does not equal 8, then no solution will ever work for the variable. If it's always true, where 5 is equal to 5 or -2 is equal to -2, you're going to write all real numbers. In both cases, the variable is eliminated, so the variable goes away. So if you look at these last two examples here, I'm going to distribute the 8 through both terms, then distribute the 10 through both terms on the right. 40x minus 16 is equal to 320 plus 40x. When I subtract 40x from both sides, you'll notice there's a 40x on both sides. So 40x take away 40x cancels. I bring down the -16 equals, bring down the 320, and the 40x and -40x cancel. -16 is never equivalent to 320, so this would be no solution. Notice my variable disappeared, and I was left with a false statement. On the other side here, I'm going to distribute 4 through. 4m plus 80 is equal to, when I distribute a fifth through, it's like dividing by 5. So 20 divided by 5 is 4m, and then 400 divided by 5 is 80. When I subtract 4m from both sides, you'll notice it goes away. And so we are left with 80 is equal to 80. This is always true. So what we're really saying is, what's the value of the variable that makes this true? It doesn't matter. You can plug in any number. All real numbers will make 80 equal 80. Okay, so you might get some special answers like that in your homework. We've got a perimeter problem for geometry. So we're going to find the value of x so that the perimeter of the two figures would be the same. In this particular case, to find perimeter, remember you add up all the sides. So this first rectangle, its perimeter would be 6 plus 6 plus x, or another way to say that is 12 plus 2x. In this other rectangle, I've got an x over here and a 2x plus 2. So my perimeter here would equal all of that added up. So I might actually write that down. Another way to say that is twice the one measurement plus twice the other measurement. A little easier to say. So twice x and twice 6, which is 12. So perimeter of 1 equals perimeter of 2. Perimeter 1, we already simplified. 2x plus 12. Perimeter 2, I'd rather just simplify it within my equation. I need 2 of those x sides added together, twice the x, plus twice the 2x plus 2 sides. And so that side's a little complicated. So we're just going to go ahead and clean up that right-hand side. When I'm cleaning up one side, I just write down the stuff from the left. Write down 2x, distribute the 2 through, lots of 2's here, plus 4x plus 4. Before I clean up across the equal sign, if you notice, I want to clean all of this mess up. So 2x plus 12 is fine. We're going to leave that alone. 2x plus 4x makes 6x plus 4. And now we're ready to solve. I'm going to subtract 2x from both sides. By subtracting 2x from both sides, it cancels on the left. Leaves me with 12 equals 4x. Bring down the 4, positive 4. Now we're ready to solve. Subtract 4 from both sides. 8 is equal to 4x. Divide by 4, divide by 4, x is equal to 2. So it asks us to find the value of the variable that would make the two perimeters the same, and the value of that variable is 2. If you look at 2 and you plug it in, this would become 12 plus 4, which is 16. And over here, if I use 2, that would be 2. There's 4. If I plug in 2 here, I got a 6 and a 6. 12 plus 4 is 16. So the two perimeters match. One last one. Actually, I'm going to give this one. We're going to do this one in class as a warm-up. So, lesson summary, if I can get it to work here. Gave you a freebie. And then show all your work of that particular equation. Good luck.